Okay, so we're all constantly hearing about ChatGPT and AI art, right? But the real AI revolution, the one that's going to change everything, is happening a little deeper, at a really fundamental level. Today, we're going to pull back that curtain and see where this technology is actually headed beyond all the hype. Look, most of us have played around with an AI. You type something in and it feels like pure magic when it works. But that magic has its limits. And to really understand the future of AI, we've got to start with the invisible walls today's tech keeps slamming into. It's those walls that are preventing AI from taking the next giant leap. All right, first up, let's cut through the noise. The AI we use every single day, well, it's built on a foundation that's got some pretty deep fundamental cracks. And honestly, understanding those cracks is the absolute key to seeing what's coming next. This quote from AI researcher Ben Goertzel, it just nails the problem. Large language models, LLMs, they're brilliant mimics. They scan unbelievable amounts of data and get scarily good at predicting the next word in a sentence. But here's the thing, they aren't truly understanding or abstracting principles. They're masters of imitation, not genuine innovation. And one of the wildest symptoms of this is a problem called catastrophic forgetting. Seriously, just imagine this. You ask a student to summarize a huge textbook, and they do an amazing job. But then, after they read just one new page, their entire understanding of the book just evaporates. It turns into nonsense. That's basically what happens to these models. New information doesn't build on the old stuff. It just overwrites it.
And this chart? This shows you exactly what that breakdown looks like in the real world. You see an AI model learning, getting better and better, hitting almost 67% accuracy. But then, after just one more tiny step of learning, its memory completely collapses. Its accuracy just tanks to a level that's actually worse than before it even started. This isn't just a small bug, it's a total system failure that proves we can't just keep making these models bigger and bigger forever.
So, how do we fix this, right? Well, to get past these limits, researchers are building completely new kinds of AI from the ground up. We're talking about machines designed not just to imitate what they've seen, but to genuinely reason. And this is a really critical shift in thinking. We're moving away from these imitation engines, which are basically just statistical parrots that are amazing at matching patterns, and we're moving toward reasoning engines. These new systems are built on formal logic, which means they can actually deduce answers and even discover new knowledge they were never explicitly trained on. And what's so cool is that this isn't just one single idea. It's like a whole new frontier is opening up, with a few really exciting paths forward. Researchers are merging the fluid learning of neural nets with the strict rules of logic. They're building AIs that can improve themselves without that catastrophic forgetting, and even teaching AI the fundamental rules of math from scratch. Let's zoom in on that first one, neurosymbolic AI. This is basically a hybrid model that gets the best of both worlds. It uses the neural networks for what they're great at, learning from messy, real-world data, but it wraps that learning in a rigid, trustworthy system of logic. The two parts aren't separate, they work together as one. And if you want to see just how powerful this is, get this. Google's Alpha Geometry, which is a neurosymbolic system, was tested on 30 of the absolute hardest problems from the International Math Olympiad. It solved 25 of them. Just think about that for a second. The previous best AI, it only solved 10. This new approach is performing at the level of a human gold medalist. It's a huge leap. Okay, so once an AI can actually reason logically, what's the next step? Well, you connect it to the physical world. We are right on the edge of AI moving from just processing bits on a computer to actually manipulating atoms out here in our reality. This prediction from NVIDIA's CEO Jensen Huang, it might sound a little wild, but it really captures just how fast this is all happening. The intelligence that we've been building in this digital space is finally getting a body, and that is going to change, well, everything about how we interact with the world around us. And look, this isn't some far-off sci-fi dream. This stuff is already happening. We have warehouses that run themselves, cars navigating city streets, and even drones that can act on their own without a human in the loop. The key difference here is that these systems aren't just seeing a flat 2D image. They're building a true 3D model of the world, which allows them to perceive, reason, and act all on their own. So we've seen these incredible new approaches that let AI reason and act. But the big question is, why do they work so much better? For this part, we're going to zoom out and look at the fundamental principles. You could almost call them the laws of physics that seem to govern how any complex intelligence comes to be. It's a pretty deep question, right?
But what's fascinating is that researchers are finding the answer might actually be yes. Whether you're looking at biology or physics or computer science, the same core principle just keeps popping up over and over again.
And that principle is called emergence. It's this beautiful idea that you don't have to design complexity directly. Instead, you just design simple parts with simple rules, and when they all interact, sophisticated and often totally unpredictable behavior just emerges. Think of an ant colony. No single ant has the blueprint, but all their simple little interactions create this incredibly complex, intelligent system. This whole process follows a really clear pattern. You start with simple building blocks and rules. Then you let them interact on a massive scale. And out of all that interaction, a new, higher level of behavior just appears. The trick here is that you're not designing the final perfect Lego castle. No, you're just designing the bricks. And then you let them loose and discover what amazing things they can build on their own. This famous quote from physics is actually a perfect analogy for the future of AI. Think of it like this. The fundamental principles like logic and geometry, they're like space-time. They create the rules that tell the AI how to learn. And then the data the AI gets, that's like matter. It reshapes that structure based on what it experiences. It's this amazing, dynamic loop between foundational rules and real-world learning. All right, let's land the plane here and bring all of this back to what it means for us right now. We've seen the limits of AI today, the big breakthroughs in reasoning, and the principles of emergence that are driving it all. So what does this mean for our immediate future? And what really critical choices do we have to make? First thing to get is that the pace of all this is changing. We're getting out of that cycle of waiting years for some huge revolutionary leap. The future is one of steady, compounding progress, a constant stream of smaller upgrades, building on each other, getting smarter and more capable literally month by month. The change is going to feel less like a sudden earthquake and more like a rising tide. This accelerating progress puts us at a huge fork in the road. One path leads to a very centralized future. Because a lot of this requires massive data and computing power, AI could end up being controlled by just a few giant companies. But the other path is a decentralized open-source future, where smaller, more efficient models can be run by anyone, which would fuel innovation all over the world.
And look, no matter which path we go down, it forces us to ask some of the biggest questions we've ever faced as a society. We're talking about massive economic displacement from automation, and what we do about that. Who is ultimately responsible for making sure this technology is safe? And how do we make sure that the immense wealth it creates actually benefits everyone, not just a handful of people?
So to sum it all up, this next chapter of AI is a really profound shift. We're leaving the era of pure imitation behind, and we're entering an era where AI can reason with actual logic, understand the 3D world, and take autonomous action inside of it. So what does this all really mean? This technology is no longer just a clever tool. It is becoming an active agent in our world. The question isn't if this is going to happen, but how we're going to guide it. The choices that we all make, starting right now, are going to shape that future. So the real question we have to ask ourselves is, are we ready?